Solving equations using visual models. We're asked to model an equation that requires fewer than 15 positive algebra tiles. We're supposed to choose an equation that requires 1 tiles on both sides of the equation. Solve the equation visually using the model, and then check your solution, which we'll do algebraically. To solve this problem, I'm going to use PolyPad. So I go to mathagon.org/polypad, and I'm going to go to algebra and specifically the algebra tiles. In this problem, we're asked to only work with positive algebra tiles, so we're just going to be working with the tiles up here, and we're only going to be working with single variables, just the x's, so it really limits us to what we're using here. I'm going to go ahead and drag out some x values, which gives me 3x, and I'll add in some 1's as well. So that's going to be one side of my equation. The next thing I want to do now is to do the other side of the equation. So there's like an equal sign in between here. So I've got 2 x's this time, and I'm going to add in 4 1's. Effectively now, I've got an equation that says 3x plus 3 is equal to 2x plus 4. How am I going to solve that problem visually? To do this, I'm going to start by sort of canceling things out from one side or the other. So here, I've got 2 x's. I'm going to take those away, and I'm going to take them away from the other side as well. So remember, if we're working with sort of the balance concept, whatever I take away from one side, I have to take away from the other to keep things in balance. So by taking 2x from both sides, it doesn't change the fact that this remaining part of my equation is still equal. I don't have any more x's, so I'm going to have to leave this x here. But I do have 3 1's, so I'm going to go ahead and move them out of the way. And do the same here. I've got 3 1's. I'm going to move them out of the way. What I'm left with gives me my answer to what x is equal to. In this case, x is equal to 1. Let's see what happens now when we go back and try and solve it algebraically. So I've brought in the graphic that I had from PolyPad. It's showing the equation, and now I'm going to transfer that from a concrete example or a model into a mathematical model or into an algebraic model. So here I've got 3 x's, and I've got 3 1's. Here I've got 2 x's, and I've got 4 1's. To write that as an equation now, I have 3x plus 3 is equal to 2x plus 4. My previous solution that I did with a model gave me that x was equal to 1. Let's see what happens now when I tackle this algebraically. I want to collect like terms, so in order to do that, I need to collect all the x's on one side, so I'm going to move that 2x over to the other side. To do that, I'm going to subtract 2x from both sides. So I've got 3x minus 2x plus 3 is equal to 2x minus 2x plus 4. In this case now, the 2x's will cancel each other out, which just leaves me with 4 on that side. And 3x minus 2x is just going to give me 1x. And I still have the plus 3 here. So now I've got x plus 3 equals 4. To get rid of this 3 on this side, remember I want to try to get x all by itself. To do that, I need to subtract 3 from both sides. So I've got x plus 3 minus 3 is equal to 4 minus 3. In this case, the 3's cancel each other out, so I end up with x is equal to 4 minus 3, which is equal to 1. So we can see that our algebra solution matches the model, the visual model or the concrete model that we did. The next question asks us to model an equation using 10 to 20 negative algebra tiles. Do the same thing, solve your equation first of all using the model, and then check our solution algebraically. So this time we're working exclusively with negative algebra tiles. Again, we'll go back to PolyPad for this. I've gone ahead and already created the model. I've got here negative 5x minus 4 is going to be equal to negative 4x minus 8. Let's see how it works when we kind of balance things out. First thing I'm going to do is take away those 4 x's, 4 negative x's, and match them up to the 4 negative x's on the other side. So now I've still got an equation that's in balance here because I've taken out 4x from both sides. It keeps my equation in balance. I can't take any more x's away because I've only got one of them here, and I don't have one on this side. I can take 4 singles, move them out of the way, and match them up with 4 singles over here, and put them out of the way. That leaves me with negative x is equal to negative 4. One of the things we will learn later is that we can multiply both sides by negative 1, which would then change it to x equals 4. But for now, we'll just say that negative x is equal to negative 4. Now, let's see how it works out when we try to solve it algebraically. Let's see if we get the same solution. I've imported the original model from our PolyPad, and now we're going to go ahead and translate that into algebra. So we can see here we've got negative 5x's, or 5 negative x's. So we've got negative 5x. And then here we've got 4 negative 1's, which is negative 4. Here we've got 4 negative x's, so that's negative 4. And here we've got 8 negative 1's, which gives us negative 8. Remember that there's an equal sign in between these things, so we can now say that negative 5x minus 4 is equal to negative 4x minus 8. And we need to solve for x. So I'm going to collect the like terms. I want to get my x's all together on one side. To do that, in this case, I'm going to add 5x to both sides. So that means I've got negative 5x plus 5x minus 4 is equal to negative 4x plus 5x minus 8. Here, the negative 5x and the positive 5x cancel each other out. So I'm left with negative 4 is equal to negative 4x plus 5x. That leaves us with, we can turn that around if it's easier to say 5x minus 4x, which just leaves us with 1x minus 8. Now we need to do the same thing because remember we're trying to get x all by itself. So we want to get rid of this negative 8. To get rid of the negative 8, we're going to add 8 to both sides. So in this case we've got negative 4 plus 8 is going to be equal to x minus 8 plus 8. Negative 4 plus 8 leaves us with 4 is equal to x, and of course the negative 8 and the plus 8 cancel out, so we end up with an answer that says x is equal to 4, which is exactly what we did here. We found that x was equal to 4 when we did the visual model. For the next question, we're going to do a model using 20 algebra tiles this time. On one side of the equation, we're going to have x tiles and 1 tiles. On the other side, we're going to have x tiles and negative 1 tiles. Go through the same process of solving the equation visually, and then come back and we'll check it algebraically. So we go over to PolyPad again, and I've gone ahead and I've recreated a model here that uses 20 different components. You can see I've got 6 x's and 2 1's, and on the other side of the equation, I've got 4 x's and 8 1's. I'm going to start my process by doing canceling like I've done previously. So I can go ahead and move those 4 out of the way, as long as I match them up with 4 from the other side. Because I've taken the same thing away from both sides, I've still got an equation that is equal. So things have remained in balance. The trick now, though, is that I don't have anything else to cancel out. I've got 2 x's over here. I don't have any more x's on this side. I have 2 positive 1's here, and I only have negative 1's on this side. However, the process is really the same as we've been doing in algebra. In order to get rid of something on one side, you need to subtract it from that side. So I'm going to go ahead and I'm going to change those into negatives, and that moves them onto the other side. Because I've changed their sign, I'm moving them over. So now I've got 2x is equal to negative 10. I'm going to go ahead and split these. Now by reorienting things a little bit here, you can see now the way things kind of match up. We've still got 2 x's on this side and 10 negative 1's on that side. However, by splitting them, we can see that we can kind of group them here in one group there and one group here. And the two groups are exactly the same. So I can really now just see that for each x that I've got, I get 5 negative 1's. So this x has 5 negative 1's associated with it. and this x has 5 negative ones associated with it as well. Let's see how that works out when we try to do it algebraically. So remember, we're working with an equation, so there's effectively an equal sign between here. What I've got, if I look at this, I've got 6x, and I've got 2 1s. Here, I've got 4x, and then here, I've got negative 8. Writing that as an algebraic equation, I have 6x plus 2 is equal to 4x minus 8. Following through the process now, I'm going to subtract 4x from both sides, so I've got 6x minus 4x plus 2 is equal to 4x minus 8. That's going to cause those 4x's to cancel each other out, so I end up with negative 8 on that side, and on this side I've got 6x minus 4x, which gives me 2x, and then I still have the plus 2 there. So I've got 2x plus 2 equals negative 8. Now I want to get rid of the plus 2 by subtracting it from both sides. That means those 2's cancel each other out. I end up with 2x is equal to negative 8, subtracting another negative 2, leaves us with negative 10 as we expected. And now I'm going to divide both sides by 2. Leaves me with x on one side. Negative 10 divided by 2 is negative 5. So that's exactly what we found when we did the modeling visually.